Hello, I'm going to help show you how to calculate the distance in between 2 points on the coordinate plane with this video. And I'm going to start off with one that I hope is pretty straightforward. You can see the blue point and the red point on the coordinate plane. Now we want to calculate how far is it in between those 2 points. Now in a problem like this, you might look at this and go, well, if I'm trying to figure out how far it is in between them, all I really have to do is I just have to count how many intervals it is in between the blue and the red. And when I look at it, I see 1, 2, 3, 4, 5, 6, and 7 units. So the distance between these 2 points is 7 units. But then I also look at it and go, well, what's another way to figure that out other than just counting? Because maybe sometimes they're really far apart. Or maybe those points are at decimal locations, and what can we do to calculate how far apart they are? Well, that's where I come back and I look at the coordinates at these 2 points. My first one is at 1, 4, and my second one is at 8. Oops, let's keep this color coordinated. That one is at 8, 4. So then I look and go, well, how do I get an answer of 7 using those numbers? And here's what I look at. I notice that these 4s are the same, so they don't really do anything for us because I notice it doesn't go anywhere up and down in between blue and red. But if I look at the 1 and the 8, those two numbers in this case are going to help me figure out how long that segment is. And when I look at it, I go, well, how did I get the number 7 using the numbers 1 and 8? Well, many of you hopefully are seeing this. We could take 1 minus, or excuse me, let me say that again, 8 minus 1, and that's going to put us at 7. So what we did is we subtracted the distance, or subtracted those two coordinates to find the distance in between those 2 points. So when I come down into this one, I have my red point, I have my blue point. I want to figure out how far is it in between these 2 points. Right here. And again, we could count it, and we'd notice there's 1, 2, 3, 4, 5, 6, and 7. I gave you 2 examples where the distance in between the 2 points is 7. But now this time it's not 8 and it's not 1, but this time notice the coordinates at our 2 points. This one here is at -2, -4, and this one is at 5, -4. So you go, well, how do I get 7 out of those? Well, same thing. In the previous example, we subtracted those two numbers. So if we take the 5, I always like to start with the larger of the 2 numbers, and then if we subtract the smaller of the 2 numbers, which is -2, if I look at 5 minus -2, we end up with 5 plus 2, which still puts us at 7 units for the distance in between our 2 points. Probably should have put my label on this one as well. So whether we count the distance in between or we subtract the coordinates, we're going to end up with the same distance between our 2 points. Well, what happens when those points are going, call it, up and down? Well, not really any different. We can still look at this and go, how far is it in between them? And I can count 1, 2, 3, 4, 5, 6, 7, 8. So distance would be 8 units. But then if I look at the coordinates at these 2 points, if I look at my red point is at 2, 9, and my blue point is at 2, 1. Well, in the previous example, if you recall, we subtracted the x values. But in this one, when we look at those x values are the same number because these 2 points aren't going anywhere left or right compared to each other. But when we look at the y values, that's what's going to help us find our distance. And hopefully you're thinking, well, in the last ones we subtracted, we can do the same thing here. So if we take our larger of the 2 numbers, the 9, and then we subtract the smaller of the 2 numbers, the 1, well, 9 minus 1 is still 8 units. Distance between our 2 points is 8 units. Come down here. Same type of problem. How far is it in between our 2 points? We could count it, but we can also take a look at our coordinates. And my red point is at 4, 5, and my blue point is at 4, -5. So how far is it in between them? Well, I like to go back to my subtracting problem. I'm going to take the larger, the 5, from right here, because my x values are the same, so I don't need to really worry about those. And now I'm going to look at my y value at the blue point. That's -5. And remember, we are going to subtract those two numbers. And 5 minus a -5 is really 5 plus 5, which pushes us at 10 units in between those 2 points. Like I said, you could also count that. That would not be a problem. But what happens when we get here and we want to calculate the distance between these 2 points? Now this becomes a little trickier because we can't try to figure out, those intervals in there. That doesn't work. The diagonal ones are not 1. We can find 1 unit, but it's not going to be, like some of you might look here and go, right there's 1 unit. But that's not really 1 unit. 1, I didn't draw this straight. And 2, even if it would go through this point right here, the diagonal across there is more than 1 unit, so that wouldn't work. So what do we do to figure out the distance in between these 2 points? Well, in this, what we're going to do is we're going to go back to the Pythagorean Theorem. We are going to look at this as a right triangle. So what we have to do is we actually have to make the right triangle first. That distance in between the blue point and the red point is going to be the hypotenuse of our right triangle. So then we need to make the legs. Well, on the coordinate plane, everything going x direction and everything going y direction, in other words, x-axis, y-axis, those are perpendicular. So that's going to make our right angle. So what I do is I start at one of my points, and I'm going to run horizontally until I get to the other point, below or above it. So there's one leg, and then the other one, I'm going to go from my other point, and then in this case, I'm going to go down until I get to my other point, and I have a right triangle there. Now, I can look at, well, how long is that green length? Again, we could count it, or we could use numbers, but here I have 1, 2, 3, 4, 5. This one is 5 long. I can go up here and go, well, this one, the leg to the right is 1, 2, 3, 4 units long. So I have a right triangle where I know the 2 legs, and I'm missing the hypotenuse, which I would call C here. Do the Pythagorean Theorem. If you remember back to the Pythagorean Theorem, it was a squared plus b squared equals c squared. And now we just plug in our numbers. So in this case, 4 is my a, 5 is my b, and c is my c, because I don't know what that is. Put the rest of my formula on it, and now I solve my little quadratic formula. Well, 4 squared is 16, so I have 16. 5 squared is 25, add that on, it's going to equal c squared. And then we have 16 plus 25, that puts us at 41 equal to c squared. If we take the square root of both sides, let me go with a different color. Whoa, so this was 41 equal to c squared. If we take the square root of both sides, we find out that c equals, now remember in an equation we're going to get plus or minus. I'm going to approximate this. I'm going to go to my calculator. I'm going to take the square root, so I push second squared and then 41 and push enter, and we get 6.4. So when I come back here, I'm going to put 6.4. Now remember, in a problem like this, the negative 6.4 doesn't really make sense. So when it's all said and done, this c is going to equal a positive 6.4 units. There is the distance in between the 2 points. And then I have one more. This one says calculate the distance between the point 3, 2 and 9, 4 on the coordinate plane. They're not plotted for us. Well, all we have to do is start off by plotting our 2 points. So it said 3, 2, so I count 3 to the right from the origin and up 2. There's the point 3, 2, and then I have the point 9, 4. So again, I go 9 to the right from the origin, up 4, and I have my point. And now we want to calculate the distance in between those 2 points. Right here. Again, I'm going to make my right triangle. The last time I made my right triangle, I think of it below the hypotenuse. This time I'm going to make it above. So I'm going to start with my purple point, and this time I'm going to go up until I would get to the height of the pink point. And then I'm going to go to the pink point, and I'm going to go to the left until I would hit the purple point above it. And now I just need to figure out how long are those two legs of my right triangle. Well, the vertical one is 2 units long. The horizontal one is 1, 2, 3, 4, 5, 6 units long. And I now have everything I need for my Pythagorean theorem. 2 is going to be my A, 6 is going to be my B, and my hypotenuse I'm going to call C again. So there's my A, my B, and my C. I just need to make sure that it's A squared plus B squared equal to C squared. And now we solve our equation. 2 squared is 4, 6 squared is 36, equal to C squared. If we add those together, we're going to have 40 equal to C squared. And now if we take the square root of both sides, we're going to have C equal to plus or minus, and we need to calculate the approximation for the square root of 40. So I go back to my calculator, second square to get the square root function, and push 40, push enter, and we get 6.3 for this one. So again, my equation would be plus or minus 6.3, but since we're trying to find the length of something, the negative doesn't make sense, and we have 6.3 units for the distance in between those 2 points. And that's going to conclude my lesson on calculating distances between 2 points on the coordinate plane.